So with that background, we are now ready to define concurrency. Concurrency is a property of systems in which several computations are executing simultaneously and potentially interacting with each other. As an example of concurrent programs, in this course we'll look at multi-threaded processes or multi-threaded programs. However, the concurrency concepts that we discuss in context of multi-threaded processes would also be applicable to concurrently running processes. Note that the multiple threads that are running concurrently inside a process, they interact with each other through shared memory. So for instance, it is possible that multiple threads are trying to read and write into the same global variable at the same time. Because of these requirements, it is important to take great care in writing these concurrent programs. Otherwise, they could lead to nasty bugs, as we will see shortly. Let's take an example to understand what can go wrong when multiple threads are trying to read and write concurrently from a shared data structure. Imagine that we have a shared queue as shown here, and there are two separate threads T1 and T2 that want to add an element to the end of this queue. So currently there are these 5 elements in the queue. The next available slot is at index 5. This is the 6th spot in the queue, and these two threads would like to add 2 more elements, perhaps at these 2 subsequent locations. So to achieve this, to accomplish this, both the threads T1 and T2, they execute these instructions. So note that next slot is the variable which points to the index of the next available slot in the queue. So each thread will say first queue next slot equal to its data item, so it will insert its data item in the next available slot, and then the thread will increment this variable next slot by 1 to point to the subsequent location, which is now the new next available slot. So let's assume that thread T1 wants to add 17 in the queue and thread T2 wants to add 82. If everything goes according to the plan, and let's say thread T1 is scheduled first and allowed to complete, followed by thread T2, our queue would look something like this. Recall that on the previous slide, the next available slot was pointing here at index 5. So when thread T1 came in, it executed queue next slot equal to data. Its data item 17 got copied here in index 5. Next, when T1 said next slot plus plus, the next available slot became incremented and started pointing to index 6. After that, when thread T2 came in and it said queue next slot equal to data, its data item 82 got copied in index 6. And when thread T2 did next slot plus plus, the next slot variable incremented to point to the next available slot 7 as shown over here. Now, what can go wrong with this sequence of instructions? Recall, a context switch can occur at any point between the two statements of a thread. As we have seen earlier, it is possible that thread T1 gets to execute, let's say, just the first statement, and it is suspended out of the CPU. Now thread T2 comes in, T2 completes both the statements. When it finishes, thread T1 gets the chance to execute, and then it comes back to execute its last statement. If this happens, let's see how this will play out for our shared queue. So recall, initially the value of next slot was 5. Now T1 gets to execute its first instruction, which is queue next slot equal to data. So this will copy the T1's data 17 at position 5. Now even before thread T1 has had an opportunity to increment this variable next slot by 1 to point to the next available spot 6, there is a context switch. T1 is suspended out of the CPU and T2 comes in. Now the T2 also executes both the statements. So T2 executes the first statement, queue next slot equal to data. Recall, the data item that T2 is trying to add is 82. Now note that the value of next slot was not incremented by T1. It was suspended before that. So the next slot is still pointing to the same index 5. And therefore when T2 executes its first statement, it will overwrite the 17 that was written by T1. So the 17 would be overwritten by 82. Let's assume that T2 is allowed to finish. So next T2 will increment the variable next slot by 1. So this now starts pointing to index 6. When T2 finishes, T1 comes back and it is allowed to execute its last statement, which is next slot plus plus. So now you see this next slot would be moved further from 6 to 7. So what has happened due to this unpredicted context switch and interleaving of instructions across threads? First, we have lost the data item 17, which was the data item from thread T1. T1 was trying to add 17. And second, if we continue like this, you note that the next data item that would be added now would be at slot 7. We are leaving these gaps in the shared queue.